right, so today's inquiry task, we are going to be finding the area of a parallelogram. So you probably remember from yesterday's guided notes that the shape that you see here is called a parallelogram. Now a parallelogram, the definition is, well, first of all, it's a quadrilateral, so it has four sides, and the opposite sides are of equal length and are parallel. So those sides are of equal length and are parallel. So how might I use that information to find the area of this shape? Now, remember that the area of a shape, think of it like lawn versus fences. So the area is the lawn that covers the space, and the perimeter would be the fence that would be around it. Okay, so use that information to try to figure out what is the area of that shape. Go ahead and pause the video while you think about how you can figure it out. All right, so you are back. Presumably you are ready to figure out how we can find this area. So what I'd like you to do now is a brief exercise that sort of hopefully will guide you to how you get there. Okay, so what I'd like you to do is on an extra piece of paper, I want you to draw a rectangle. It can be any size. So I've drawn a couple of rectangles here to prove a point, but I'd like you to just draw out some rectangles. You can pause the video while you go ahead and do that, and then cut them out. So I'll do that here. So let's take, it doesn't matter what size they are. I'm just gonna cut it out this way. All right. Now, if I were to calculate the area of this rectangle, I know that the formula for finding area of the rectangle is going to be area equals length times width. Okay, so I'm going to use that formula to figure out the area of this rectangle. My length, 1, 2, 3, 4, 5, 6, 7, 8 by 1, 2, 3, 4, 5. So this is going to be, the length is 8 by 5. So my area is 40. So 40 centimeters squared. That's the area of that rectangle. Okay, now what I'd like you to do is with your rectangle, yours can be any other size dimension, doesn't have to be the same as mine. I want you to take it anywhere at all. It can be here, it can be here, it can be there, it doesn't matter. I would like you to make a single diagonal cut. Boop. Okay, so now you have your rectangle in two pieces. Now, I'd like you to take, so your two pieces kind of fit together like that. I'd like you to take your pieces, and then you are going to put them together on the straight edge side. Now, what is the new shape that we have just made? If you said parallelogram, you are absolutely right. So the new shape we have here is a parallelogram. You can just see that the parallelogram is the exact same thing of the rectangle, but presented in a different way. Okay, so that area of that parallelogram is going to have the same area as that rectangle. Okay, so how can you use that thinking to go back to our original parallelogram, and how can you find the area? Go ahead and pause the video while you use that thinking to help you figure that out. Okay, so if you are back, you are probably ready for the big reveal. Okay, so I know that there is a relationship between the area of a rectangle and the area of a parallelogram. Okay, so if I take that and I flip it around here, I'm gonna have my parallelogram. So I can go ahead and let's try to find how I would figure out what the dimensions are of this parallelogram using that thinking. So if I count my length, 1, 2, 3, 4, 5, 6, 7, 8, I still have a length of 8. Now, I also know that I can count up the height of my, of my parallelogram. So I can count 1, 2, 3, 4, 5. It still has a height of 5. So my parallelogram, to calculate the area, I can still do 8 by 5. So that means I can do, for this one, the base, or the length of the parallelogram, times what we call the height. And that will give me the area of the whole thing because I know that I can work that same relationship. So this has a base of 1, 2, 3, 4, 5, 6. This has a height of 3. So I can do 6 times 3 is going to give me 18 centimeters square. So if I want to undo that and prove it, what I can do is I could cut out this parallelogram. So I actually have that conveniently here. I can go ahead and cut that out. How can I prove that it's pretty much just finding the area of the rectangle? Okay, so I have that there. It's the same thing as the base times the height. What I'm doing, in essence, if I cut off this end here, boop, and I take that and I turn it this way, all I have is a rectangle. It's just a regular rectangle. So that formula being length times the width, or the other way around, length times the width, so it's still 6 times 3 is 18. So we know that there is a relationship between finding the area of a rectangle and finding the area of a parallelogram.